Today we'll be talking about the following 5 Venn diagram questions, and by the end of this video, you'll know some really easy tricks so you know how to answer them. The timestamps will refer to when we talk about each of those questions. It's Rami here, let's get into the first question. I'll assume you know how to draw Venn diagrams and why we use them, and although we can use them to represent frequencies, outcomes, or probabilities, we'll focus on probabilities in the Venn diagrams in this video, but the same rules apply for Venn diagrams involving frequencies or outcomes as well. In order to cover the tricks that you can use in an exam to select the correct regions, we'll complete our first question. I've copied the following question here for your convenience, and before we cover it, just to give a quick recap, the complement of an event A, or not A, represents the probabilities that do not belong to the event A. So if this is region A, then A complement must be this region. And now we've clarified that, let's find the probability of A complement intersect B. In the first step, I like to start off by drawing separate blank Venn diagrams for the individual events and the final Venn diagram we want. I'm going to draw 3 Venn diagrams out, one for A complement, one for event B, and one for the actual answer we want, A complement intersect B. When doing these sketches, you can do this very roughly to save some time, so this really should only take a matter of seconds. In the second step, we're now going to shade the regions for the individual events A complement and B on their separate Venn diagrams. Looking at A complement, as mentioned previously, these represent the probabilities that do not belong to the event A. In other words, it's everything outside the event A, so this is the region that we're going to shade. For event B, we just shade that region B. And then in the third step, we want to shade the correct region or regions for A complement intersect B. This is where we're going to learn a new trick, and in order to do that, let's familiarize ourselves with what the term intersect actually means. Generally speaking, the word intersect means for items to overlap each other. So if we were to draw these 2 rectangles, then move them towards each other, where they overlap would be known as where they intersect. In our Venn diagram, based on this definition of what intersect means generally, it's surely where the events A complement and B overlap. We can see that it's this region right here. So moving forward, I want you to think, whenever you see the symbol intersection regarding a Venn diagram, it is the common region or shading between the 2 events that overlap. However, in an exam, I appreciate you won't have the luxury of moving shapes like this. So for this example, I'm going to look at each region separately in the blank Venn diagram to make it clear which region or regions we want to include. Let's look at each region of the Venn diagram one at a time, and the arrows will direct to which part I'm talking about. Looking at the outside region, this is shaded for A complement, but not for B, and since there's no common shading, we don't include it. Looking at this region, this is not included as it's not shaded in either region. Looking at the intersect of A and B, this is shaded for B, but not for A complement, and since this is not common shading, we don't include it. Looking at this region, this is shaded for A complement and it's also shaded for B. And since this is common shading, we therefore do include this. And as a result, the probability of A complement intersect B is 0.2. So notice this Venn diagram shading technique is a powerful way of working out the regions that we want. Let's try another example involving intersection, then we can move on to a case involving the union notation. Let's talk about this question, and for this one, we'll speed up the process a bit. Let's draw 3 Venn diagrams, one for event A, one for B complement, and one for A intersect B complement. Again, we'll shade the regions for A and B complement for their separate Venn diagrams, and just remember that we want the common region or shading between the 2 events that overlap. Looking at the outside region, this is shaded for B complement, but not for A, and since there's no common shading, we don't include it. Looking at this region, this is shaded for B complement, and it's also shaded for A, and since there is common shading, therefore we do include this. Looking at the intersect of A and B, this is shaded for A but not for B complement, and since there's no common shading, we don't include it. Looking at this region, this is not included since it's not shaded in either region, and as a result, the probability of A intersects B complement is 0.25. As you may have noticed, so far we've talked about the complement notation with intersection, but now we'll talk about this question that involves the union notation. I've copied the following question here for your convenience, and we want to find the probability of A complement union B. In the first step, like previously, I like to start off by drawing separate Venn diagrams for the individual events that we want and the final result. One for A complement, one for B, and one for A complement union B. In the second step, we'll shade the regions for the individual events A complement and B. And then in the third step, we'll shade the relevant region or regions for A complement union B. This is where we're going to learn a new trick, and in order to do that, let's familiarize ourselves with what the term union actually means. The word union means the action of joining certain items or things together. So if we draw these two rectangles, then move them towards each other, the union of them would be this shape right here. I almost want you to think of this as the region where the two parts are merged together to form a new shape. So in our Venn diagram, based on this definition of what union means generally, surely it's the region where A complement or B are shaded. And this does indeed hold true for probability. So we can see that it's this combined region here. So moving forward, I want you to think whenever you see the union symbol regarding a Venn diagram, it's the combined region or shading between the two events. However, like last time, I appreciate that you can't move shapes like this when you're in an exam, so we'll look at each region separately to make it clear. Just remember, this time, as we're dealing with the union notation, we're not merely looking for common shading anymore. We look for the combined shadings. Looking at the outside region, although it is not shaded for B, it is shaded for A complement, so we will include this. Looking at this region, this is not shaded in either region, so we won't include this. Looking at the region that's the intersection, although it's not shaded for A complement, it is for B, so we will include this. Looking at this region, this is shaded for A complement, and it's also shaded for B, and since it's shaded in both, we will include this. However, even if it was only shaded in one of them, we'd still have this included anyway, as we're looking for the combined shadings. As a result, the probability of A complement union B is 0.75. Let's try another example involving union. For this new question, let's draw the three Venn diagrams, one for event A, one for B complement, and one for A union B complement. Again, we'll shade the regions for A and B complement for their respective Venn diagrams. Looking at the outside region, although it is not shaded for A, it is shaded for B complement, so we will include this. Looking at this region, this is shaded for B complement, and it's shaded for A too. Since it's shaded in both, we'll include this. But, as mentioned previously, even if it was shaded in only one of them, we'd still include it. Looking at the region that's the intersection, although this is not shaded for B complement, it is for A, so we will include this. And looking at this region, this is not included in either of them, so we did not include this. As a result, the probability of A union B complement is 0.8. Let's look at one final example. For this new question, it would be preferable to draw Venn diagrams for events A, B, A union B, and A union B or complement. So 4 diagrams makes more sense this time. Again, we'll shade the regions for A and for B in separate Venn diagrams. And next, we're dealing with union notation, so when combining the shadings, it's the larger region right here. Now, when looking at the complement part, everything that was shaded will now be excluded, whereas the parts that were not shaded will now be included. So we just shade the outer part of the two ovals. And the probability of A union B all complement is 0.4. Now we've covered the Venn diagram shading method using complement, union, and intersection, you'll now have the skills to tackle some similar questions yourselves. So that's going to do it. I hope you managed to get something out of today's video. Don't forget to subscribe for more free content just like this, and turn on all notifications so you don't miss any uploads from this channel. If you have any questions, just pop them in the comment section below. Thanks for watching, and I'll catch you in the next video.